Viewers, I welcome you back to RemedialOne YouTube channel where we discuss awake math questions with the strategies and the simple way to solve it so that you can get your maximum points. Myself, Samuel Abebrese here, and US, I teach math, and my colleague from Pemper College, Mr. Samuel Boatin.
Thank you so much, Abed. Once again, we are solving mathematics past question. We have made a lot of videos. In the last video, we did something on indices. And we said that indices, we will select questions on simplification and evaluation. So today, viewers, we want to solve WAEC past questions on indices which involve equations. On the screen, we have our first question. We want to solve equations which involve indices. First, have to establish that the indices in the questions are in the same base. So, for example, e raised to the power x is equal to e power y. So if you have something like this, when you look at the left-hand side, the base is p. The right-hand side, the base is also p. So if you have this, then you equate the exponent. You equate the exponent. And then there's another one, another concept, p to the power x is equal to q to the power x. Yes, this one, the exponent are equal, so you equate the base. So these are the two main concepts that we use to solve equations which involve indices. So let's come back to the question. 4 to the power 2 minus x times 16 raised to the power x plus 1 is equal to 64. So let's check all the indices. The first term, this one 4. And then when you come to the 16, the 4 and then 16, different base. Then the right answer is 64. So we need to, we have the same base, a common base, so that we can equate the exponent. So 16 can be expressed in terms of 4. So 4 raised to the power 2 minus x times 4 to the power 2 times x plus 1 is equal to 4 to the power 3. 64 can be written as that. Now, someone can also express all of them in terms of 2. But let's use this one. So on the left-hand side, according to the laws of indices, if the bases are the same and then they are multiplied, you add the exponent. So this implies that, next step, 4 to the power plus 2 bracket open x plus 1 is equal to 4 to the power 3. So we have been able to simplify the left-hand side. So we can now equate the exponent and solve for our x. So since the bases are the same, you can underline the base for 4. Okay, we can equate the exponent. So this implies that plus is equal to 3. So this is a simple linear equation. So we can expand. This implies that, 2 minus x plus 2x plus 2 is equal to 3. So we can group the like terms. 2 plus 4 on the left-hand side minus x plus 2x is equal to 3. So this is 4 plus x is equal to 3. So we have the x, we want to find x. We send the 4 to the other side. 3 minus 4. So x is equal to minus 1. We have another question. If 1 on 2 times into bracket 81 raised to the power n is equal to 1 on 54. Find n. So as I said in the first question, to solve a question which involves indices, or to solve an equation which involves indices, you always have to establish that both sides of the equation have been expressed in a common base. Like that. First, let's rewrite the question. You can write it as 81 raised to the power n on 2 is equal to 1 on 54. So with this, care must be taken here. We can rewrite it as 81. This implies that 81 raised to the power n is equal to 2 on 54. Yes, 2 will go here. Yes, we multiply 2 by 2. So 1 on 27. That's one of the properties of indices. If you have 1 over something, you can write it as m raised to the power minus 1. Next step, this implies that you can rewrite 1 on 27, 81 raised to the power n is equal to 27 raised to the power minus 1. So with this, you have to express both the left and then the right-hand side in a common base. Now looking at the numbers 81 and 27, you realize that when you can express them both the left and then the right-hand side in terms of 3. So this implies that 81 can be written as 3 raised to the power 4n, yes, which is equal to 3 raised to the power 3 times minus 1. So 27 is the same as 3 raised to the power 3. 81 is the same as 3 raised to the power 4. Okay. So the bases are the same. On the left-hand side, we have 3. The right-hand side, we have 3. So we equate the exponent. We have 4n is equal to minus 3. So we want to find n. We divide both sides by 4. We have our n to be minus 3 on 4. That is the final answer. We have another question on the screen. This is really technical. This is really technical. It's true that you make sure both sides are expressed as common base. But this one, you need to do some simplification before you can use that concept. So first, the question is, if 3 raised to the power x plus 3 raised to the power x plus 1 is equal to 36, we have to find x. This implies that, let's simplify this one a little bit. So we can write it as 3 raised to the power x plus 3 raised to the power x times, yes, 3 raised to the power 1 is equal to 36. Yes, so we expanded 3 raised to the power x plus 1. Why are we doing that? Because of this plus, you can't really express them as a common base. So we need to factorize 3 raised to the power x out. We need to factorize 3 raised to the power x before we can make use of that concept. So this implies that let's factorize 3 raised to the power x. Yes, bracket open. So it will be left with 1 here plus 3 here equal to 36. So now this implies that the next step, so 3 raised to the power x, 1 plus 3 will give you 4, which is equal to 36. So we first have to divide both sides by 4. So the 4 will cancel 4. Then you have 3 raised to the power x, which is equal to 9. So with this, then we can apply the concept that if the bases are the same, you equate the exponent. So on the right hand side, we have 9. So we can write 9 in terms of 3. Can express 9 if the bases are the same. Therefore, x is equal to 2. Viewers, this type of question, take note of it. It's very tricky. Viewers, I have a similar question for you. So you can pause and then solve this one. It's the same as the previous one that we saw. So you can pause and then solve it. Later, you check the answer. I guess you were able to do it. Okay, let's all go through it. So if 2 raised to the power x plus 2 raised to the power x plus 1 equal to 48. So this one you cannot do it straightforward. You need to simplify some aspect as we did in our last question. So 2 raised to the power x, then we simplify this plus 2 raised to the power x times 2 raised to the power 1 equal to 48. So let me remind you that this is about laws of indices. Imply that next step, we factorize 2 raised to the power x out, bracket open. We have 1 plus 2, which is equal to 48. So this implies that 2 raised to the power x, 1 plus 2 will give you 3, which is equal to 48. So let's first divide through by 3. So on the left hand side, 3 will cancel 3. Then you get 2 raised to the power x equal to 16. 3 will go into 48 16 times. This implies that so we can express 16 in terms of 2. So 16 is the same as 2 raised to the power 4. So therefore, if the bases are the same, then you equate the exponent. So x will be equal to 4. And I hope you got it correct. If 16 raised to the power n is equal to the cube root of 2 into bracket 2 raised to the power 2, find the value of n. Remind you that any time you are given a question on indices, your motive is to make sure that the bases that you are working with are the same. The cube root of m is the same as m raised to the power 1/3. So let's go back to the question. So on the left-hand side, this implies that we have 16 to the power n is equal to, so we can rewrite the right-hand side as 2 raised to the power 2 in bracket all raised to the power 1/3. So 16 raised to the power n is equal to, now on the right-hand side, we have 2 raised to the power 2 times 1/3 as one of the laws of indices. Yes. Okay. So we can now, here the base is 2. We can now express 16 in terms of 2. Because the base on the right-hand side is 2. So 2 raised to the power 16 can be written as 2 raised to the power 4. And we already have n there. Multiplying n equal to 2 raised to the power 2 on 3. Okay. So on the left, the base is 2. On the right, the base is 2. So we can go back to our concept that if the bases are the same, 4n is equal to 2 on 3 on 1 over 1, 2 on 3. Okay. So we cross multiply. Yes. So 4n times 3 will give you 12n is equal to 1 times 2 will give you 2. And since we want to find n, we divide both sides 12. Yeah. And 2 will go into 12 6 times, which will go into 1. 2 will go into 1, 2, 1, and then 12 6 times. So our answer is n is equal to 1 on 6. If 9 to the power x times 3 to the power 2y equal to 1 on 729, then we have another equation, 2 raised to the power minus x times 4 raised to the power minus y is equal to 1 on 8. This is simultaneous equation which involves indices. The concept is the same. So we have two equations. We need to simplify the equation or simplify the indices to generate our equation. That's what I mean. Okay. So for the first equation, so let's make use of the laws and then properties to simplify them. So for the first equation, we have 3 raised to the power x, the base is 9, and then 3 raised to the power 2y equal to 1 on 729. So 3 raised to the power x, we can rewrite 9 in terms of 3 as 3 raised to the power 2. Times 3 raised to the power 2, 9 raised to the power minus 1. So we have 3 to the power 2x times 3 to the power 2y is equal to 3 raised to the power 6. 729 can be written as 3 raised to the power 6. So multiplying the power minus 1. So on the left-hand side, we have 2 indices multiplying. So according to the laws, when you are multiplying, you add the exponent. So we have 3 raised to the power 2x plus 2y is equal to 3 raised to the power minus 6 to be 3. So we can comfortably equate the exponent. This implies that 2x plus 2y is equal to minus 6. Yes, equation 1. But we can simplify the equation. 2 minus 6. 2 can go into minus 6. So we have, let's divide through by 2. Then we have x plus y is equal to 2 going to minus 6 minus 3. So that is our first equation. And then we move on to the second equation. You first generate your equation before you solve them. Or you use the properties and laws of indices to do that. So here we have 2 raised to the power minus x times, as usual, let's express 4 in terms of 2. Yes, is equal to 8 to the power minus 1. You have 2 raised to the power minus x times 2 raised to the power minus 2y is equal to 8 can be expressed as 2 raised to the power 3 times minus 1. So on the left-hand side, we have 2 in this. So we add the exponent. So minus x, 2 raised to the power minus x plus minus 2y is equal to 2 raised to the power minus 3. So once again, the bases are the same. So we can equate the exponent. So we have, therefore, minus x minus plus minus give you minus 2y is equal to minus 3. And we have minus. We can divide through or multiply through by minus. X plus 2y is equal to 3. That is our equation 2. Can we take it to the next page? Now we have our 2 equations. The first one is x plus y equal to minus 3. Then equation 1. Equation 2, x plus 2y equal to 3. Equation 2. Now, how do we solve simultaneous equation? There are several ways of doing that. You can use elimination method. You can use substitution method. You can use graph. By looking at the equation, we can easily use elimination method. But in the first equation, we have x, the coefficient is 1. In the second equation, we have another x, the coefficient is also 1. So we can easily eliminate x and reduce it to a linear equation and then solve it. So let's write equation 1 minus equation 2. Good. Minus x will give you 0. And then y minus 2y will give you minus y, which is equal to minus 3 minus 3 will give you minus 6. So we want to find y. Y will be equal to 6. You then put this one in any of the two equations to find the value of x. You can put y is equal to 6 in equation 1. You can put y is equal to equation 6 in equation 2. So let's plug y is equal to 6 into equation 1. So wherever you see x, you put. So x plus 6 is equal to minus 3. To find x, we send the other 6. So minus 3 minus 6. So x is equal to minus 3 minus 6 minus 9. So remember, you can also have simultaneous equation which involve indices. So when you are given such a question, as we have done, you generate your equation first before you use the concept in solving simultaneous equation to solve this. Viewers, so soon, this is where we will end for today's lesson. As we have said, this channel is dedicated to solve WAEC past questions in mathematics. So, if you really want to pass and pass well, just visit this channel, RemedialOne channel, all the time, and you will enjoy our solve past questions here. God bless you. If you want further clarification, or if you don't understand anything, you can go to our channel and then write your comments, or you can call us. Yes, that's my number on the screen. Don't hesitate to call me if you don't understand what we have done here, or if you want further clarification. Now, if you want to see me in person, I'm in Ramper College. So you can call me and we meet. God bless you. Continue to enjoy watching this channel. Bye.
Bye-bye, guys.